Proceed to import the gears from the tool library. Remember that the module of the gears to be meshed must be the same to achieve a correct mechanical relationship, which in this case is 0.5. Proceed to position the gears at the correct distance. This distance can be calculated as 2 times the sum of the pitch diameters of each gear, divided by 2. In this case, the distance is already set by the 2 holes. Define the optimal initial position, using the tangential relationship between the teeth. Now, remove this relationship to proceed with establishing the mechanical relationship. In the mechanical relationship, you must select a curved surface on each gear. In the pop-up field of each gear, enter the value of its pitch diameter, dp, 5 mm for the small gear and 7 mm for the large gear. Check its functionality. Finally, insert the elements to establish the universal joint relationship. To establish the initial position, you must restrict the position and mobility of the parts in a specific way. It is important that, in the universal joint, you have left visible the sketch of a central axis, which extends from the base to the upper axis, or, for simplicity, from the lower hole to the upper hole. Align the ends of the sketches to define their initial position. Set the indicated faces parallel. Now that the initial position has been defined, proceed to remove the previous relationships to correctly establish the mechanical relationship. select the cylindrical bodies and the pivot point around which they will rotate. Finally, check its functionality. Great. To practice, try to do it by yourself by looking at the drawing and following these steps. Good luck. Congratulations on completing the mechanical relationships section in SolidWorks. If you found the video useful and it helped you in any way, I encourage you to like it and subscribe, as this greatly helps us continue to generate more quality content.